Welcome back, students. In this video we are going to discussing about the image formation by a concave mirror. That is, which type of image is obtained when we place an object in front of a concave or a converging mirror, and what changes happens to the image when we change the position of object. Already we know that in order to obtain an image, the reflected light rays must be intersected or seems to be intersected at a particular point. If it actually intersects at a point, then we obtain a real image, and if the reflected light rays are only seems to be intersected at a point, then we obtain a virtual image. When we place an object in front of any type of mirror, whether it is a plane mirror or concave or convex mirror, different light rays, that means from that object a large number of light rays falls on this particular mirror, and after reflection these light rays are bounced back. So in order to study the nature and characteristics of the image, with the help of this ray diagram, we have to first draw a neat ray diagram. In order to draw the ray diagram, it is not possible to consider all the light rays falls on this mirror, because if you draw all the incident light rays and reflected light rays, then the diagram will not be a neat one, and it is not possible to identify the characteristics of image. So in order to obtain image, light rays must be intersected. So in order to intersect, minimum 2 light rays are enough, and obtaining the point of intersection where it is intersected after reflection. In case of this concave mirror, we can consider 6 different positions of object. That is, we can place object at 6 different positions in front of this concave mirror, and depending upon that positions, different types of images are obtained, that we have to discuss with the help of ray diagram. Before drawing a ray diagram, certain points you have to keep in mind. First one is, here in case of concave mirror we are drawing the ray diagram. First you have to draw a concave mirror, then mark its pole, then center of curvature, then draw the principal axis and mark the point principal focus. So all the conditions should be maintained. That means focus should be at the center of that center of curvature and pole. That is, distance between pole and focus, that should be equal to the distance between focus and center of curvature. From each and every point of that object, different number of light rays should fall on that mirror, and after reflection it will be intersected. But to obtain a neat and legible ray diagram, we are only considering 2 light rays from the top point of that object and 2 light rays from the bottom point. And also one more point you have to keep in mind, there is no need of drawing these incident light rays from the bottom point, because the bottom point of that object we are always considering in contact with the principal axis. Okay, now let us go to the 6 different cases. And the first case of this concave mirror, we are considering the object at infinity. Case 1, object at infinity. That is, the object is placed very far away from the mirror. A normal example we can consider, if we are considering the sun as an object in front of a small concave mirror. So what happens when we are considering an object at infinity or very far away from the concave mirror? And from that object we are only considering 2 light rays, and from a far away object almost all the incident light rays should be parallel, because the light source is very far away from that mirror, and from that light source millions of light rays are emitted in all directions, and from that one we are only considering two incident light rays, and that will be considered, or that should be, we can consider almost a parallel. And that kind of a two parallel light rays we are considering here. The parallel light rays from that far away object falls on that mirror. What will happens after reflection? That light ray should pass through the focus. That is the condition we already learned, and we can see that light rays are intersected at the focus. When two light rays are actually intersected at a point after reflection, we obtain a real image. So in this case, when the object is at infinity, the concave mirror produces a real, inverted and highly diminished or a point-sized image at the principal focus. Then case 2, object just beyond the center of curvature, or object behind the center of curvature. And just if we are considering an object in contact with the principal axis, just behind the center of curvature of that mirror, and from the topmost point of that object we have to consider any two light rays. First one we are considering parallel to principal axis, and other one we can consider passing through the focus. Among that four types of light rays, any one we can consider, but here we consider one is parallel to the principal axis and other one passing through the focus. Then after reflection, what happens? The parallel light ray should be passed through the focus, and the light ray which is passing through the focus after reflection moves parallel to the principal axis. And just looking that or observing that reflected light rays, you can see that reflected light rays are intersected at a point, and just join that point with the principal axis. That gives the corresponding image, because corresponding to the topmost point we obtain that intersected point, and from the bottom point, if we are considering any kind of that conditions, that light ray should be reflected back through the focus, and corresponding to that point, just join that two points where the reflected light rays are intersected to the principal axis. That gives the image. And here also the reflected light rays are actually intersected, so the image is a real one, and real images are always inverted. Then what about the size? Size of that image is smaller than that of the object, or a diminished or a smaller image. And where it is formed, it is obtained between F and C. So the image formed is a real, inverted, diminished image is formed between C and F when the object is placed beyond the center of curvature. Case 3, object at the center of curvature. When we place an object at the center of curvature of a concave mirror, just considering an object and two light rays from the topmost point of the object, bottom point should be through the principal axis. So first one is considering parallel to principal axis, and after reflection it will move through the focus. The next one we can consider the light ray which is passing through the focus. And what will happen if the light ray is passing through the focus? After reflection it will move parallel to the principal axis, and here also we obtain an intersecting point. Just join that point with the principal axis, and that gives the corresponding image. Here also the reflected light rays are actually intersected, so the image will be a real one. Real images are always inverted. And what about the size? The image will be the same size as that of the object, and it is formed at the center of curvature. That is, when we place an object at the center of curvature of a concave mirror, it provides real, inverted and same sized image at the center of curvature. Case 4, object placed between C and F. that is, an object is placed between the center of curvature and focus of a concave mirror. Considering that object, and we are considering two light rays from the top point of the object. One is parallel to the principal axis, and the second one we can consider passing through the focus. The incident light ray, which is parallel to principal axis, after reflection moves through the focus, and the light ray which is passing through the focus after reflection moves parallel to the principal axis. And here also we can see that the reflected light rays are intersected at a particular point, and just join that point with the principal axis, that gives the corresponding image. Same way here also the reflected light rays are actually intersected, so the image will be a real one. Real images are always inverted, and the size of that image we can see that is greater than the object, that is an enlarged image, and it is formed where that image is obtained. It is obtained beyond the center of curvature. It is when an object is placed between C and F of a concave mirror, it provides a real, inverted and enlarged image beyond the center of curvature. In case 5, when we place the object at the focus. Just considering an object at the focus of a concave mirror, and from the top point we are considering two light rays. Consider a light ray which is passing through the center of curvature, and another one directed towards the pole of the concave mirror. The light ray which is passing through the center of curvature bounces back through the same path, and the light ray which is strikes at the pole bounces back by making equal angle with the principal axis. Here you can see that these two reflected light rays, they are moving parallel to each other. They are not intersecting anywhere. So there is a possibility of intersection for at infinity only. If we are extending these reflected light rays, there is a possibility of intersection at infinity. So a real, inverted and highly enlarged image may be obtained at infinity. When the object is placed at the focus of the concave mirror, a real, inverted and highly enlarged image is obtained at infinity. The last and the sixth case, object between F and P of a concave mirror. That is, object is placed between the focus and pole of the mirror, very close to that mirror. And considering that object, and from the top point of that object we can consider two light rays. One is passing through the center of curvature, which is bounced back through the same path after reflection, and another one strikes at the pole of the concave mirror. Then the light ray which is incident at the pole reflects back by making equal angle with the principal axis. And here you can see that the two reflected light rays are diverged to different directions. It means they are not intersecting and they are not parallel, but they are moving in either directions. So what you can see, just we can extend the back point of that reflected light rays. Since they are diverging to different directions, these light rays must be originated from a point. So just extending that reflected light rays, we can see that the two light rays seems to be diverging from a point behind the mirror. Here the reflected light rays are only seems to be intersected at a point, so that should be a virtual image. When an object is placed between the P and F of a concave mirror, it provides a virtual, erect and enlarged image behind the mirror. Here the only situation where the concave mirror provides a virtual image. Virtual images are always erect in nature. Okay students, you can try out the ray diagrams using other two conditions which we are not used here. We already learned 4 conditions, and in these ray diagrams we are only used 2 conditions, so among that 4 you can try out these ray diagrams with the help of other conditions, other possible conditions, and the same kind of image you will be obtained at the same locations, satisfying all the same characteristics.